So let me share my screen. And today we'll be talking about functions. So we finished our unit on we finished the unit on the inequalities. We did absolute value, and we also did the compound inequalities last time. So hopefully everybody did the homework and did it well. So I think that went fine. We also did linear equations and basic operations. So that basically all followed the same type of principles, right? It's all just what? It's all just inverse operations was the big thing for that one. So today we will be just going into another direction where we are going to be doing some functions, which we're not exactly going to be solving anything yet, but we're just going to be introduced into functions because they're going to be very important later on when you have higher levels of math. So if you can see the screen, say yes in the chat. If you cannot, say no. All right, so hopefully everybody can see the screen. Okay. So we'll be first going over homework questions over the inequalities. So I'm just going to give you, I think there's like 5 problems. I'm just going to give you a few minutes for each one to just post your answers and try to solve it. All right, so let's check the answers for this. So I think people got x is greater than 5 and 13/17. Okay, that's a weird number, but I don't know. Let's see. Okay, so let me see who answered here. So Brayden, Denny, Zemo, and Yuchen all got greater than or equal to 513 over 17. So I think that should be the correct answer. Let's see what it is. So do I have any volunteers that would like to work on this? Okay, Ivan. Ivan, how did you solve this?
So first, I multiply both sides by 7 to cancel out the over 7. And then I got 3x plus 14x, so that's 17x, is greater than equal to 98. So then I divided 17 on both sides to get 98 over 17, or I think simplified is 513 over 17. But
There's
anyways,
no need. Again, do not simplify this ever. There is literally no need to ever simplify this. This is fine. If you put
then,
it into this, this is not simplifying, this making it more complicated. Do not do this. It makes it harder to work with.
so then it's square brackets 98 over 17 to infinity, and then close dot on the number line.
Yes. So let's see. Like this is good. Okay, so this is a review of what we did last time. So now a square brackets right to infinity. Okay, very good. Let's go next. Okay, let's go over the problems. Okay, I don't know how you got 8 is less than 1 and 1/2. How is 8 less than 1.5? I'm assuming that's an x. Okay, anyways, x is less than 1.5. So I think most people got x is less than 1.5, so we should have that. Okay, very good. Now, who else wants to volunteer for this one? Let's choose someone different this time. Ivan again? Okay, that's fine. How did you solve this?
So first, you divide 8 on both sides to get rid of the times 8, and you get 1 plus 2x is less than 4. minus 1 on both sides, you get 2x is less than 3, and then divide 2 to get rid of the 2x, and be left with x. X is less than 3 over 2, and it's parentheses, 3 over 2 infinity. Okay, I got it. No, negative infinity. I got it. I got you.
Negative infinity to 3 over 2, right?
Yeah, and then the number line is open circle.
Right, and that's to the left. Okay, very good. We will now continue. So, let's go. Number 3 here. All right, let's go over this one. So let's see here. -5 is less than whatever this is, less than or equal to -3. So it is going to be a compound inequality. So let's see how you guys did on that. Okay, so we have some different answers here. I think most of you got -26. Well, x is in between -26 and -14. Aaron got -26 to -20. Yuchen got -31 to 5. So we have some different answers here. So who wants to volunteer? If not, I can call in somebody. Are there any volunteers? Okay, if not, then Aaron, can you explain your answer?
Okay.
First, I multiplied by 6, which I got negative.
Whoa. No need to multiply by 6. Move this first. So if you move this, what do you get?
You get negative 4.
Negative 4. Okay, this is the
Is less than x plus 3 over 6. This, which is less than or equal to negative 2.
Okay. So now what do you do with the 6?
You multiply everything by 6.
Okay. Okay, so now to get the x by itself, you have to move the 2.
这个图这边，这个图这每 i 转的减一个2。I know， 我说这个图这边，这个图这边。i 转减一个2，这是。
So where are you going to move it?
To both sides.
You subtract 2 from both sides.
Okay, so you subtract 2 from both sides. You have to do this. So whoever got negative 26 to negative 14 is correct. Okay, so make sure you check your work with this. You have to move the negative 1 first. Do not multiply by 6 first because it will be very annoying. Because then you have to also you also have to multiply every term. If you were to multiply by 6, then you have to do annoying things like, okay, so if you did this, let me see.
为什么这个这么薄？
Okay, anyways, if you were to multiply by 6, you have to do negative 30, okay, x plus 2, but you also have to multiply this by 6. Then you will get the same answer. Okay, or not. Did you get the same answer? But no, this is negative 18. Then you would get the same answer. Okay, so clearly this is negative 26 to 14, negative 14 here, square brackets. And you're going to have negative 26 here. You're going to have negative 14 here. You're going to have a open circle. That was not open. Open circle and a closed circle here. This one is inclusive. This one is not inclusive. So you have open circle and then closed circle. Okay, are there any questions?
No.
If there are no questions, then we will continue. All right, the next one, I'll give you a few moments to do this.
Yeah, 所以都
Who is unmuted? Please mute your mic. Okay, let's go over this one. So let's see who has answers. Okay, so Denny says negative 17 to 25. Okay. Zemo says basically the same thing. Okay, and Aaron also, but there's less than negative 21, and Yuchen is just x is greater than 3. So, Yuchen, can you explain your answer?
Hmm?
Can you explain your answer?
I don't think I got it right, but
Okay, so how did you do this?
why me again? I think I forgot to multiply by 7 in the first place.
You forgot to multiply by 7?
Yeah.
Actually, you did this last time, right?
Yeah.
Okay, so what do you think this is equal to? Just like straight off the bat, you can tell.
No solution, empty set. Absolute value can't be negative.
No. It's greater than a negative. So it's the other one. It's all real solutions, right?
Oh yeah.
So there's two special occasions.
All right.
This one is no solution, and then it can also be all real numbers. So this one is all real numbers. Okay, why? Because it is greater than a negative, and
Oh
no
yeah.
matter what you plug on there, it is always going to be greater than negative. It's
Oh yeah.
always going to be greater than negative 21. Okay, so you can plug on negative 64 in here, and it will still
Oh
be
yeah.
greater than negative. So this is why. Okay, always greater than negative. So whoever just solved that just now, you probably did something wrong. You can't solve these. So
Yeah.
you can just tell now, straight off the bat. Okay, so that is that. Special case, make sure you remember them. Okay, so you can tell next time. 4x over 6 minus 1 is greater than 9. Okay. So, I'll give you a few minutes to do this, and then we'll go to our let me see. Yeah, our functions. All right. So let's look at the answers for this one. So we have Yu Chen says it is what? All real numbers. I don't know if that was for the last one or this one, but it's probably for the last one. Okay, anyways. Zemo says greater than 15 or less than -15. Okay. That could be possible. But we also have Braden saying it's in between -15/4 and 15/4. So Danny says in between -15 and 15. Okay. So we have some different answers here. Let me try to go through this, see what it is here. Obviously, we have to move the 1 here and then divide by 6. So we have 10/6. Okay. Nope. It is 10 times 6. 10 times 6. Because this is a fraction. So you have to do that. So let me see here. This is going to be greater than 60. Remember, when it's greater, it's going to be an or, an equality. So you have to do 4x is greater than 60 and 4x is less than -60 and solve them separately. That's the or thing. It's greater than 15, it should be less than -15. So whoever got this, good job. Now let's go on to the interval notation. It's going to be actually it's -infinity to -15 here, union 15 to infinity. So let's see what that is. Okay. So now if we plot it, it's going to look different than a compound one. Open circles, of course. It's going to branch out like that. That is the mark of an or inequality. So make sure you pay attention to that. Okay. Now let's go to our actual things that we need to do today. Or not. Oh, that's where I went. Okay, so let's just talk about the coordinate plane first, and then we'll talk about functions, apparently. All right, let's go. So now we'll talk about the coordinate plane. Hopefully everybody has seen this before. So if you've seen it in class or something, you should have seen something like this coordinate plane. Basically, you plot points. See, this is the x-axis. It's the y-axis. Okay, like that. And x is horizontal, y is going to be vertical. So let's see here. First, let me talk about how to plot points in general. You're going to put the x-coordinate first, okay? X-axis coordinate, and you're going to put the y-axis coordinates second. So if you want to plot a point here, okay, let's see what that is. 1, 2, 3, 4. Okay, so the x-axis is going to be 4. 1, 2, 3, 4, 5, 6, 7. About 7, I think. Okay, so this would be 4 7s, obviously. Right, if you go horizontal first and you go vertical, obviously if it's below this line, it's going to be negative. Here it's going to be negative. So let me talk about quadrants. Okay, so quadrants, Q1, Q2, Q3, Q4. So quadrant 1, quadrant 2, quadrant 3, quadrant 4. Let me talk about what each of these are. So in quadrant 1, both of them are positive. Positive. Okay? Both x and y are positive in quadrant 1. You're going to have to remember that because it's important later on. Now let's go on to this. In quadrant 2, what is negative? X is negative. Y is still positive. But in quadrant 3, see, they're both negative. They're both negative. Okay. In quadrant 4, y is negative, x is positive. Okay, so what are the importances of these quadrants is just because you know when things are negative, when things are not. Sometimes you're probably going to encounter quadrant 1 the most. You're definitely going to encounter quadrant 1 the most because quadrant 1 is when we work with objects in real life, right? If you're counting money, you can't really have negative money unless you're in debt, but usually they don't put that in calculations or mix them up. Okay, that's a bad example. Let's say you have apples. You cannot have negative apples, right? And let's say you trade bananas for apples. For every apple, you get 2 bananas, okay? Then, you know, you put it on this graph, and there's only going to be quadrant 1 because you can only have positive numbers of those things. You're usually going to be using quadrant 1 only. So you're going to see this. Okay, and that's your graph. So that's coordinate plane. But now let's go on to some distance formula. So can everybody tell me what the Pythagorean theorem is? So hopefully everybody knows what the Pythagorean theorem is. So can everybody in the chat put what the Pythagorean theorem is? Okay. Okay, so now let's look at chat and see what everybody thinks. Pythagorean theorem is okay, so a squared plus b squared is equal to c squared. All right, so everybody knows. Okay, so is there anybody that is not familiar with this? Okay, if everybody is familiar with the Pythagorean theorem, then we can go on to the distance formula. So the distance formula, basically Pythagorean theorem. Okay, Pythagorean theorem is that important. So Pythagorean theorem is very important, and when you're doing geometry, it's basically a foundational theorem. You're going to be using Pythagorean theorem in geometry, calculus, trigonometry, that kind of stuff. Very important. So make sure you know what the Pythagorean theorem is. Let me just write it up here. And we can now begin to see how to find the distance formula. So let's say we have 2 points here. Okay, let's call this x1, y1, x2, y2. These are general points, they're variables. Okay, if you wanted to find the segment or the length of the segment, how do you find that, right? Obviously, if you had this, you can find it because it's horizontal and you could just use the x-axis, or if you had a vertical one, it's very easy, right? But what if it's diagonal? Then you can't do it by counting. But we can do it because we have the Pythagorean theorem. You can make a triangle out of anything. When in doubt, draw triangles. Not squares or rectangles or anything else, because there's so much trigonometry or triangle math that you can do. So as you can see, you can draw a triangle here, or I can draw it up top if you want, but please don't do that. It looks weird. Anyways, so as you can see, you draw a triangle here, right? Now let's recall what the Pythagorean theorem actually is. The Pythagorean theorem is for right triangles. And as you can see, we can draw a right triangle from most things here. You draw a line. If you have a line here, you can have a right triangle. So for right triangles, A, B, C, a squared plus b squared is equal to c squared. Now I ask you, what is this triangle? What are the segments of these triangles? if we can find the lengths of these legs, then we can use the Pythagorean theorem to find the distance. Right? But how do you do that? To do that, all we need to do is we take y1 minus y2 and x2 minus x1. As you can see, it's pretty self-explanatory, right? You have two coordinates. To find the displacement between those two coordinates, you can simply use y1 minus y2 and x2 minus x1. Now that you have the legs, all you have to do is to sub them in for a and b. So substitute them in. It's gonna look like this. Okay, and that's equal to c squared. In this case, it's d. And you take the square root, that's gonna actually equal to d. All right. So, are there any questions on this? Okay, so this is the general formula. Hopefully everybody takes notes on this. So if you have a notebook out, take notes on this one. This is the general formula. Okay. So now we will continue to the midpoint formula. So we have a couple formulas here. These two are probably the big ones that you need to know. On the homework, there will be certain problems that need you to use these formulas. On the homework today, there's 4 problems. 3 are required. Number 4 is optional because it is a bit confusing. 4 basically uses all of these formulas. So make sure you can use that correctly. So let's go here. Midpoint formula. The midpoint is actually much easier to understand than the last one. If you have 2 points, you want to find the midpoint between them on a segment. How do you find that? Well, midpoint is just the middle, right? To find the middle of something, you just divide it by 2. So how do we apply that? If we have x1 and y1, here we have x2, y2 here. How do we find, the middle of these coordinates? Well, you just add them up and divide them by 2. So it's very self-explanatory here. x1 plus x2 over 2. And then you have y1 plus y2 over 2 to get the midpoint. Okay, and that gives you the coordinate. Are there any questions? If there are no questions, then we'll continue. So now let's go over domain and range and what we're trying to do really with functions. So domain and range, you can think of them as input and output. Remember to put domain as the input, range as the output. So when you are you see those machines, right? Or let's think of something here. An ATM. ATM is a machine. What would the input of an ATM be? It would be your credit card or your card details or your password. Something like that would be the input of the ATM. What is the output? The output would be cash, right? Once you put your card information in or your password or whatever you do in ATM, it will output cash for you. In this case, the domain would be the password or the credit card, and the range, the output would be the cash. So you can think of input and output that way. You can also think of input and output as the independent variable and the dependent variable. If you ever learn science, you can also put this as the independent and the dependent. Okay, what does that mean? In an experiment, for example, a science experiment, independent variable means that's the thing that's being changed, and y, or the range, depends on the domain or the independent function or independent variable, okay? So let's say you're doing an experiment on growing a tree. You have 2 trees. One tree is going to be in the dark. It's not going to get any sunlight whatsoever. The other tree is going to get a lot of sunlight. And you compare its growth after maybe 6 weeks. Okay, so what is the independent variable? That would be what? The amount of sunlight would be the independent variable. That is the domain. Now let's talk about what is the range. The range, okay, would be what depends on the domain. Okay, after the independent variable is changed, what is changed because of that? Then that would be growth. Because you change the sunlight, you change the growth of whatever, right? All right. So now we will go to actual definition of domain. Okay. So the domain is in our studies or whatever this is would be the x values. Okay, and then range would be y values. So always remember x-axis as the independent variable or the domain. Y is just going to be the range. Okay, always. So now let's do some practice on what this is. Okay. So let me see here. If we had, you know, like this. Okay. And we also had this. Okay. Let's say this is a certain function. Okay, this could definitely be a function, or actually you don't know what a function is, so I'm just gonna say a graph. Okay. So to find the domain of this graph, you do all the what? You do all the x values. So how do you do all the x values? Let's say this is -5, this is 4, this is 7. Okay, as an x values. Okay. So we have the domain. We have -5 to 4. Again, this is not inclusive because it's open circle. Union just 7. That would just be the domain. List of all the x values. Okay, so if there are only points, if you have a discrete graph, which means you have points like this, you're only listing the x coordinates of the points. Now, if you have like a continuous graph like this one right here, then you have to list an interval notation. Now for range, it's the exact same. Range is exact same. So you can figure that out. So now let's go on to functions. So functions just the correspondence between the domain and the range. You can think of functions as a machine. The functions is the ATM. Okay. So we talked about independent variable, your credit card information. Dependent variable is the money that you get out of it. The machine or the function is actually the ATM. Think of this. If the function, the domain goes in, range comes out. Let me give you an example. F of x is equal to 3x plus 5. Okay, this is the domain, x, or the independent variable that you put in. This is the range. So what does that mean? F of 3 is going to be 3 times 3 plus 5. This is the domain. This is the range, okay? Now let's talk about some specific things that you can't do with functions. So, 1x cannot have multiple y's, but one y can have multiple domains or x's.
I think I've learned this before, like one input cannot map to multiple outputs, but multiple inputs can map to one output.
Yeah, that's it. Okay. So now yeah, we can actually have a test with this. Okay, so good point to bring up here. You're gonna actually test if something is a function. So Yuchen, while you brought it up, I'm just going to ask you to quickly help me with this for this demonstration here. So if you have a graph here, okay, let's say this is our graph, right? Actually, no, let's change it. Okay, what if I wanted something cooler, like this? Is this graph, right? Okay, so Yuchen, would this be a function or not?
No, since in a function, no x value can repeat, even though no y value can repeat, despite some x values being.
Right, so I think what you mean to say, no y value can repeat for one x, right?
Yeah.
So for this, we can conduct a vertical line test. Vertical line test, okay? If there's multiple points of intersection with one vertical line, it is not a function. So only this, where it passes the vertical line test, it works. All right. So now we will continue to some practice problems. Simple application of distance formula. So we'll see how that goes. Okay, so let's just quickly go through this. So the distance between 2 points. Okay, let me just get someone to volunteer with this. So clearly this is the formula, right? This is going to be equal to d. Actually, we don't need to volunteer for this. It's just x1 minus x2. You can choose anyone since they're squared, doesn't matter. Okay, you can choose this like this. Okay, just make sure that x1 and y1 are in the same point. So you can't just be switching up in the middle. Right, so now let's look at this. X1 minus x2, so that's 4 minus 2, and then y1 minus y2, which is 9 minus 3. We have 2 squared, which is 4, plus 6 squared, which is 36. So we have a square root of 40, and I don't know if you know how to simplify these yet, so we're just going to keep it as square root of 40. All right. That's how you find the distance between 2 points using the distance formula. Now let's go on to the segment here. Okay, if the coordinates of P, Q, and A, okay, are 2, 6, 5, 9, and 3, 10, respectively, find the length of segment AF. All right. Let me just remind you that F is the midpoint of PQ, segment PQ. Okay, so let's look at this. Segment AB bisects section segment PQ at point F. That is fine. We know the coordinates are of PQ are what? Well, P is 2, 6. Okay. And Q is what? Is 5, 9. So let me see. What else do we know? 3 times. Okay. So this is where you have to use both of your formulas. So I need to have somebody volunteer here. So who thinks they're up for the challenge? Or not? It's not really a challenge. Who wants to volunteer? Any volunteers that would like to help me solve this? If not, I'll just do it. Okay. So let me see here. You need to find the midpoint. This is just the midpoint would be 7/2 and then 15/2 using our midpoint formula. We add those, okay? And then we find the distance between the midpoint here, F and A, to find the length of the segment AF, okay? And I'm pretty sure you know how to do that, okay? So what is this? 15/2 is what? 7.5, and 7/2 is 3.5. So once you figure out the decimals and stuff, you can probably do it. We are running out of time, so I won't do the hard calculations. This is just how you solve the problem. Now we have to go find the domain of stuff. So this is just quick, go over this. We won't be doing much with this. But you will see this on your homework, and it's pretty easy to do. So let's just go on and I'll show you what to do here. So when you find the domain of something, you need to think about what cannot exist. When you find the domain of f of x, okay, when you plug anything for x, plug anything in for x, any real number here, 1000 to the fourth, does that exist? Yes, there's a number that equals 1000 to the fourth. What about negative 1000 to the fourth? There's a number that equals negative 1000 to the fourth. That exists. So this domain is negative infinity to infinity. Everything exists. You can plug anything into this. Okay. Now let's go to find the domain of this. Okay, so this is a little bit different. This is a little bit different. Because what are the restrictions here? So let me see. Yushen, can you just quickly volunteer for a second or help me demonstrate this?
Wait, what?
Yeah, I'm just gonna quickly walk you through this one. Okay, so can you just tell me what are the restrictions? Just quickly tell me what are the restrictions to square root?
And to be rational, what's inside them must be a perfect square.
No, it's
No, wait.
let me see. Can't be negative, right? It can't be negative.
Yeah, it can't be negative.
Exactly. So that's a restriction, right?
Yeah.
So when you find the domain of f of x, can you have a negative in here? Will it
No.
exist if there's a negative? Exactly. So that's why you cannot have a negative in here. That is restriction. That is the domain. The domain is everything minus the restrictions. So this can't be negative, right? This cannot be negative. So this
Yeah.
has to be greater than or equal to 0. That's the domain. Then you solve it. Obviously, it's going to be greater than or equal to 2. Because if it's anything less than or equal to 2, for example, 1, it's going to be 1/2 minus 1, and you're going to have a negative in your square root, which does not work.
Yeah.
This would be the domain. So I'm gonna since you did well on this one, I'm gonna have you do the next one too. So this one is same thing. Okay. Restrictions.
3x plus
What do you
5
think?
cannot be equal to 0.
Very good. So you cannot have 0 in the denominator, right? So that is exactly correct. And that would be the restrictions. Basically, the only 2 restrictions that we're really doing in Algebra 1 is these 2. Square roots and can't divide by 0, right?
Yeah.
So once you do this, you can basically just solve it. I mean, 3x cannot be equal to -5. 3x cannot be equal to -5/3. It's going to be -infinity to -5/3 union -5/3 to infinity. That's how it does.
Yeah.
Okay. So thank you for demonstrating this. That is, I think, all for today. So it's not too hard, the domain stuff. Make sure you know your midpoint and your distance calculations, and then you'll be fine on the homework. Okay, thank you for coming, and I'll see you next week.
All right. Thanks.
Thank you.
Signing off.
Bye. Thank
Bye.
you.
Bye. Signing off.
Yep.